Okay. So on Thursday, we did some of the matrix operations. And today we're going to expand it to a larger matrix. Once we go beyond 2 equations, 2 variables, anything by hand really becomes very tedious. I will show you one of these by hand, and then we will default to the technology just because one problem can take like 10 minutes to solve, and it's honestly not worth it. So we will work this one out, and then from there we will work with the technology, just because in the real world, you guys have access to technology to help you guys get those answers. It's then being able to take the answer and make sure you can explain what it means. So we have 3 variables, 3 equations. 3x1 plus x2 minus 2x3 equals 2. x1 minus 2x2 plus x3 equals 3. And 2x1 minus x2 minus 3x3 equals 3. So before I even put this in a matrix, I always know we want to start with that 1 in that upper left corner. So I'm going to flip-flop these 2 to begin with, so that when I write them, I already have a 1 in that upper left-hand corner. So when I go to my matrix, I'm going to write the second one first. So 1, -2, 1, 3. Then 3, 1, -2, 2. 2, -1, -3, 3. So the process alternates 1s, then 0s, 1s, then 0s, 1, then 0s. That's the process we're always going to follow. So get your 1 by either your multiplication or division, or in this case, we already have it. And then you get your 0s by your multiply by the opposite and then add. So times by the opposite and then add the rows. And then we default back to 1s again. So we get the 1 and then we get the 0. So just alternates between get your 1s, get your 0s. So our 1 is already here. So what we need to get is 0s beneath it. So we got to get a 0 here and a 0 here. So what do I need to multiply by to cancel out 3? We multiply by the opposite. The opposite of 3 is -3. So I'm going to take -3 times row 1, add it to row 2. And that's going to go back into row 2. And then I'm also going to list what I'm going to do to cancel out that bottom row there. I'm going to multiply, if I want to get rid of 2, I'm going to multiply by -2. So -2 times row 1, add it to row 3 is going to replace row 3. So I am not touching the top row. So I'm going to take -3 times 1, it's -3, add it to 3, 0. -3 times the top one, so -3 times -2 is 6. 6 plus 1 is 7. 1 times -3 is -3, plus -2 is -5. 3 times -3 is -9, plus 2 is -7. So I have done that row. Now I'm going to do the same thing with the bottom row, except I'm going to multiply by -2. So 1 times -2 is -2, add it to do, cancels out. -2 times -2 is 4. 4 plus -1 is 3. 1 times -2 is -2, plus -3 is -5. 3 times -2 is -6. -6 plus 3 is -3. So step 2 is complete. So 1 we already did. That was step 2. Get our zeros. Okay, so next is going to be to get the next 1. So 1s are always on the diagonals, 0s everywhere else. So our next place we're going to get a 1 is right here. We want that to turn into a 1. So from the previous line, I'm not touching the top row. I am not touching the bottom row. I want that 7 to turn into a 1. So remember, in order to get a 1, you're going to either multiply or divide by something. So am I going to multiply or divide 7 by a number? And what am I going to do to get it to turn into 1? What number is that? Divide by 7. Okay, so I'm going to take row 2, divide by 7. So 7 divided by 7 is 1. -5 divided by 7 is going to have to stay that fraction, -5/7. And then -7 divided by 7 is -1. Okay, so step 3, done. Once the 1, next is to get the zeros above or below it. So now our goal is to get this and this to be a 0. In order to get a 0, you're going to multiply by the opposite and then add it. So row 2 is the 1 value. So I'm going to take row 2 times the opposite of row 1. That is negative. It is -2. So the opposite of -2 is 2. So 2 times row 2, add it to row 1, replace row 1. And then if I work with the bottom row, the opposite of 3 is -3. So I'm going to take -3 times the 1, which is in row 2, add it back to row 3, and replace row 3. So I'm keeping the middle row here, and everything else is going to change. So 0, 1, -5/7, -1. Not everything's going to change, but the 1's going to stay, the 0's going to stay. And the goal was, this step was to make zeros here and here. We can always double check. 2 times 1 plus -2 is in fact 0. So I'm working with these 2 rows, each pair as I work down. So then I'm going to take row 2, -5/7 times 2. That's what, -10/7. And then I need to add 1 to that. So that's -1 3/7. If I take away the 1, that leaves me -3/7. 2 times -1, so -2 plus 3 is 1. And then I'm going to repeat with the bottom row. So -3 times 1, -3 cancels out with a +3. -3 times 5/7, 15/7. That's 2 1/7, right? And then I want to take away 5. He's -3, but then I need to add 1/7. So what is that? -2 and 6/7, 7, 14, -27. I'm doing it mentally. You can always use a calculator. Last one here. -3 times -1 is 3. 3 minus 3, 0. Okay, step 4 is done. Now we have a 5 and a 6 because we have an extra row and an extra column. So before it was only 1, 2, 3, 4, but now we have 5 and 6 because we have extra row, extra column that we have to take care of. Can you understand why we don't like to do these by hand at this point? Because we've already been working for close to 10 minutes on one problem. All right, so next is to get the 1 on the next diagonal. So the 1 is found by either multiplying or dividing. And if we have a fraction, we're going to multiply by the reciprocal. So from the previous line, the top and the middle are not changing. The bottom, I'm going to multiply by the reciprocal. So take row 3 times -7/20. Multiply by 0 doesn't change those. That's going to turn into 1, and multiply by 0 is still going to keep that 0. So last step, geez, what color haven't I used yet that I can use? Orange. Is to get the zeros above. Okay, so working with row 1. I currently have -3/7, so I'm going to multiply by the opposite. So that is +3/7. So I'm going to take +3/7 times the 1, that's row 3, and then add it to row 1. Place row 1. And then we need to cancel out the -5/7, so we're going to multiply by its opposite, 5/7 times the 1 value. Add it to the row 2 value, replace row 2. So I am not touching that bottom row. The 1s and 0s do not change that are over here. So 1, 0, 0, 1, that's all carrying down. We, the only part that changes is from the pivot column that we're working with. So the column we're working with is our pivot column. All right, so 3/7 times 1 is 3/7. Subtract 3/7, 0. 3/7 times 0 is 0. 0 plus 1 is 1. And I work the next 2 rows here. 5/7 times 1 is 5/7 minus 5/7, 0. 5/7 times 0 is 0. 0 plus -1 is -1. And we have now officially found our answer. This is x1, x2, x3. So x1, first column, value is 1. Second one, there's my x2. x2 is -1. And x3 is down here. x3 is 0. 0 is an answer. 0 is a number. It is okay to see this. Okay, x3 can equal 0. That is an okay solution. Just wanted to double check. All right, lots of fun, right? I will tell you, this process alone is in fact more straightforward than had I attempted to eliminate. When I don't know what it is about elimination. Once I get to 3, more often than not, I end up making a mistake along the process of solving it with elimination. I'm a lot more likely to get it right when I do it with a matrix. But either way, it's still a lot of work involved in getting to these answers. So we will go back to our lovely Desmos calculator to help us with some of the rest of these. So we have 2x1 minus 4x2 minus x3 equals 8. 4x1 minus 8x2 plus 3x3 equals 4. negative 2x1 plus 4x2 plus x3 equals 11. So go ahead and write that one down. Then I'm going to get my Desmos calculator open. So I just type Desmos matrix in like the Google bar, and it's the first one that opens. Okay. And I'll make mine small enough to fit there so we can see my problem and my matrix calculator. Okay. Say that again.
How do you use?
Oh, back on the main homepage, there's a drop down for the different ones you can pick. On the main Desmos page, so just click Desmos back here, and then math. I think it's under Math Tools, Matrix.
Okay. Oops. You got it.
I did click the right one.
Thank you.
Yeah. So they have a bunch of different calculators. Just pick on the right one. Now we have 3 rows and 4 columns. So what I need to do is increase to 3 rows, increase to 4 columns. And then I'm just going to enter my numbers. So 2, -4, -1, 8, 4, -8, 3, 14, -2, 4, 1, and 11. Thank you. That would give me a very wrong answer. All right, so once it's entered, you just hit enter so that it has now stored matrix A as this. Then we click reduce row echelon form, matrix A. And I always click enter just so that it populates my answer over there. All right. If I look at the bottom row, it says no x1s plus no x2s plus no x3s still gives me an answer of 1. Is that possible? No. So when I look at that bottom row, this is causing a problem here. All right. It's okay. Like x3 equals 0. That's fine. This row here's fine. It says 1x1 minus 2x2s equals 0. That's fine. But there's no way to take 0 plus 0 plus 0 and make it equal 1. That's just not possible. So I always copy my matrix over here just so you can see it. Oops. 1, -2, 0, 0. 0, 0, 1, 0, 0, 0, 0, 1. Okay, so this is the problem. This is saying 0 equals 1. We know that can't happen. So what do we say? No solution. Next one. 2x1 minus 2x2s minus 4x3s equals -2. 3x1 minus 3x2 minus 6x3 equals -3. -2x1 plus 3x2 plus x3 equals 7. They're hard to read. Okay, so I'm going to make my new matrix. Again, 3 rows, 4 columns, and then I'm just going to start entering my numbers. So 2, -2, -4, -2. 3, -3, -6, -3, 2, 3, 1, and 7. And even if you hit enter and like you had a mistake, you can always go back and click on it and fix it and then hit enter and it'll fix it. So just so you know. All right, once it's in there, I'm going to reduce row echelon form it. I'm going to write down what we got here. So I have 1, 0, -5, 4, 0, 1, -3, 5, 0, 0, 0, 0. Okay. So when I look at this, the bottom row is zeros. So we're at a point where we have a condition that is, you can see here. So x1, we solved for, we got a 1. x2, we solved for. x3, somehow it deleted all the way out, and that's where I'm left. So what I'm going to do is I'm going to rewrite this out here back in the equation form. So 1x1 minus 5x3 equals 4. 1x2 minus 3x3 equals 5. So you can see that both x1 and x2 are tied to x3. The only way we can determine their value is if we know what x3 is. So x3 is the condition that we have to know first to be able to go back and solve for x1 and x2. Does that make sense? Okay, so what we do, our goal is, what is x1, what is x2, what is x3? Well, x3 is the one that we're hinging on here. So what I'm gonna do is I'm just gonna pick another letter. A lot of times what we do is t. So that's the one that's our condition. So then I'm just gonna go back here and then I can solve these. x1 minus 5t equals 4, and x2 minus 3t equals 5. And now I can find what x1 is and put it over here. I can find what x2 is and put it over here. So I would just have to add 5t to the other side. So x1 is 4 plus 5t. So as long as I know what I'm plugging in for t, I can find x1. And then the same for x2. So just subtract, or sorry, do the opposite. So add your t term to the other side. So x2 is 5 plus 3t. So this has infinitely many solutions based on whatever I plug in here for x3. So if I plug in 1, it's going to give me a different answer than if I plug in 5 or -0.5 or -6.35. That's going to give me all the potential solutions along the way. So can you see how we can find, again, a single solution, no solution, and infinite solutions, even if we have more than 2 variables? All right, so you guys just practice with the calculator really quick. We have 2x plus 4y minus 10z equals -2. 3x plus 9y minus 21z equals 0. And x plus 5y minus 12z equals 1. So go ahead, practice that one in your calculator here. Mm-hmm.
Now the third right there. All right, so let me see. So arrow back there. Okay, so into your last one. Oops, button 5 didn't go. Oh, I did the arrow instead of the tab. I wonder if that's maybe not like, there you go. Now the cursor's in there. So negative 12. No, you're fine. So add the negative, then use the arrow key, not the tab key. So arrow over 1. Once you hit enter, it should pop back up there. Okay. But you have to enter it in to say to the calculator, I'm storing this matrix. Then it'll pop up with the operations you can do. Okay. So if you don't hit enter, it won't show that yet.
All right, so 2, 4, negative 10, negative 2, 3, 9, negative 21, 0, 1, 5, negative 12, 1. We get x is negative 2, y is 3, and z is 1. Friday. So now we're going to do some word problems. So this is a number 83. Anytime the number's here, it means I just copied it from the book. So this is section 4.3 in the e-text, number 83. So it says the dietitian in a hospital is to arrange a special diet composed of 3 basic foods. The diet is to include exactly 340 units of calcium, 180 units of iron, and 220 units of vitamin A. The number of units per ounce of each special ingredient for each of the foods is indicated in the table below. So all I have is a table right now. What I need to do first is figure out where my total row or column will be, because depending on how they created it, I don't know where my total is going to be. It may be a row, it may be a column. So they give me the total of calcium, the total of iron, the total of vitamin A. So for me, in this one, the total is going to be this end column over here. So we want 340 calcium, 180 iron, and 220 vitamin A. wherever your total is, that creates where your equals is. So this is equation 1. This is equation 2. And this is equation 3. So I have 30x, 10y, 20z equals 340. 10x, 10y, 20z equals 180. 10x, 30y, 20z equals 220. Okay, so for this, the table was already set up exactly how my equations are going to look. It is set up exactly how my matrix is going to look. So could I have taken this and straight gone into the matrix? Yes. So when your total is the end column, it is set up as a matrix for you. So if I have that, then all we need to do is go over here. I'm going to make my new matrix, 3 rows, 4 columns. All right, it was 30, 10, 20. Oops, nope, go back. 20, 340. 10, 10, 20, and 180. 10, 30, 20, and it was 220, right? I think, okay.
Divide everything.
If I wanted to, yeah. So let me show you how I could do that really quick. Take D and divide by 10. So I could do that and then have smaller numbers, especially if I were going to do this by hand. Like that is something that would make the problem a lot easier for sure. Okay, so then if I wanted to, I think I can, let's see. I save that. There's a way to do it. So reduce row echelon form. So you could do D, just do D if you wanted, like that, and it's going to solve it. So X is 8, Y is 2, Z is 4. So X is 8, Y is 2, Z is 4. So now we're going to go back and explain what does that actually mean. Okay, well, if we look back at here, the X is this is the Y, this is the Z. So I need 8 units of food A plus 2 units of food B, because this all has to happen at the same time. It's not just 8 units of A gets me to what I need. It's all 3 of these combined that reach my target goal. 2 units of food B, and then 4 units of food C. So I have to have both food A, food B, and food C in different amounts to reach the target goals of those 3 vitamins / minerals. Make sense? Alrighty. So next one here. A small manufacturing plant makes 3 types of inflatable boats: a 1-person boat, a 2-person boat, and 4-person models. Each boat requires the service of 3 departments as listed in the table. Cutting, assembly, and packaging departments have available a maximum of 380, 330, and 120 labor hours per week, respectively. All right. And it says how many boats of each type. So this is X, this is Y, this is Z. Whenever it asks you how many of whatever, that's your X, Y, and Z. That's what, if you set up as your columns, are going to then get the total, set it up as a perfect matrix. All right, so our totals are 380, then 330, then 120. So from that information, I can go straight to my matrix. Here's my cursor. All right, so new matrix, again, that's a 3 by 4. So 0.5, 1, 1.5, 380. 0.6, 0.9, 1.2, 330. 0.2, 0.3, 0.5, 120. Okay, so this process, what the company is doing is they have figured out how much time it takes at each location, cutting, assembly, and packaging, for each of the 3 things they're making. They've also calculated, based on the number of employees, the max amount of hours each department can work. So what they're trying to do is figure out the most or the best possible outcome of how many boats of each type they can make in a week. Their goal is to get that optimum value with what is required and what time they have. So if I reduce this guy, I did something wrong, 0.6, there we go. So how did I know that that was wrong? When I looked at this and I see all these funky numbers here, I know I did something wrong, okay? So I look back and I said, oh, I forgot my decimal. And you can see as soon as I put that in, it automatically changes my answer down here. And then I have nice round values. You will always get nice round values when you do these word problems, okay? So X is 20, Y is 220, Z is 100. So X is 20, Y is 220, Z is 100. So the best productivity they have is 20 one-person boat, 220 two-person boats, and 100 four-person boats made per week. Make sense? All right, so we're going to go back and do, this is just a 2 by 2. So for practice, since we have a little bit of time, maybe we'll do some by hand. All right. 2 sociologists have grant money to study school busing in a particular city. They wish to conduct an opinion survey using 600 telephone contacts and 400 house contacts. Survey company A has personnel to do 30 telephone and 10 house contacts per hour. And survey company B can handle 20 telephone and 20 house contacts per hour. How many hours should be scheduled for each firm to produce exactly the number of contact hours? All right, so I'm going to show you what happens if you set up the initial table the wrong way. There's really no wrong way. It's just not set up to be matrix form right away. So I'm reading this sentence as survey A. So company A can do 30 telephone and 10 house. Survey company B can do 20 and 20. Now, it says they wish to conduct 600 telephone. So my telephone is a column. So here's my total. So 600 is down here and 400 house. So you can see how my total is now a row instead of a column. Okay? You always go from your total opposite direction to create your equations. So my equations here are 30x plus 20y equals 600. So this is x, this is y, this is the total. And then the next one is 10x plus 20y equals 400. So it's just knowing that wherever your total is, if it's a row, the equation is in a column. If it's in a column, the equations are in the rows. It's always the exact opposite of what it is. So this was not perfectly set up to be a matrix yet, because I can't enter it like this. This would not work to row reduce. It has to be in this form here in order to be able to get my answer. Okay. One extra column, then rows to get correct matrix form for systems of equations. So if you did this, in the end, we would get x is 10 hours, y is 15 hours. So that is 10 hours with A and 15 hours with B. It's combined. It's not just 10 hours at A is going to reach the goal. It's 10 hours at A plus 15 hours with B reaches my target goal. And the reason I'm clarifying that is there were a few people, when you wrote your real world explanation for the one I just graded from Thursday, some people said, oh, 50 hours reaches my 4,000 screens and 75 hours reaches my 4,000 keyboards. But no, it was 50 hours at Taiwan plus 75 hours at Mexico reached the target of both 4,000 and 4,000 screens and keyboards, whatever it ended up being. That makes sense? Okay. This is what we're gonna do on Thursday. Today we're gonna do a quick check. We are not doing one on Thursday. So you do have one today. And that is, did I post it? Where did I post it? I posted it somewhere. I don't know where I posted it. It is? I put it in a discussion this time? Okay. Thank you. I was like, I know it's somewhere. Oops. Okay, so you already got. All right. So let me zoom in on that. All right. So you guys can always do it here, just like normal. The key is turn it into your matrix, then use the Desmos matrix calculator to solve it, and then write your real world solution. And once you've posted your response, find a classmate's response and compare your answers. Okay? So find somebody that you don't end up working with here to compare with. But it says a farmer can buy 3 types of plant food. Mix A has 30 pounds of phosphoric acid, 50 pounds of nitrogen, and 30 pounds of potash. Mix B contains 30 pounds of phosphoric acid, 20 pounds of nitrogen, and 20 pounds of potash. Fixed C is 30 pounds of phosphoric acid, 25 pounds of nitrogen, and 20 pounds of potash. He needs a total of 900 pounds of phosphoric acid, 750 pounds of nitrogen, and 640 pounds of potash. So make your table. If you then need to turn it into equations to make your matrix, that's fine. It's just a matter of where your total falls, if it's a row or a column. And as always, talk to each other, figure it out.